Okay, I'm going to split this review, this quarter review, into several different videos. This first video is going to cover the first page, which is the 6 probability questions. So question number 1, 6 nickels, 8 dimes in your pocket. So that's 8 plus 6, or 14 coins total. So when I randomly pick a coin out of my pocket, there are 14 possible outcomes. I'm going to pick a coin, I'm going to put it back and draw another one. I want to know what the probability is that both coins are nickels. So probability of a nickel followed by another nickel. Well, since I'm putting the first coin back before I draw the second one, the probability that it's a nickel in the first draw is going to be the same as the probability of a nickel in the second draw. And that probability is 6 out of 14, because I have 6 nickels out of the 14 total coins. And I have that multiplication. Because we had a rule for probability that said probability that the first thing happens and then the second thing happens, we can multiply the two probabilities together. It's called the multiplication rule for probability. I can reduce 6 over 14 to 3 over 7. And then my answer will be 9 over 49. 3 times 3 is 9, 7 times 7 is 49. So there's my fraction answer. I grab a calculator and I do 9 divided by 49 to get my decimal answer. And I'm just going to round it to 4 decimal places, 0.1837. So there's my decimal answer. For my percent, I will just take my decimal answer and multiply by 100, and then it will be rounded to the nearest tenth. So 18.37% is my percent answer. I needed a fraction, a decimal, and a percent. Okay, problem number 2. Numbers 1 through 15 are written on note cards and placed in a bag. One number is drawn at random. What is the probability that the number is larger than 12? So if I listed my sample space, I would have the numbers from 1 to 15. Those are the possible outcomes. Any number from 1 to 15 is a possible outcome when I draw out of that bag. So the total number of outcomes is 15, but only 3 of those are larger than 12. So my favorable outcomes is only 3. So probability of a number greater than 12 is going to be 3 out of 15. We can reduce that by dividing out of 3. We can reduce it to 1/5. Or we could just do 3 divided by 15 and get a decimal answer. 3 divided by 15 or 1 divided by 5, they are both 0.2. There's our decimal answer. And as a percent, that is 20%. Okay, next one. Problem number 3. We have a basket that has 5 apples and 8 peaches. You randomly select one piece of fruit and eat it. You're going to select another piece of fruit. What's the probability that both pieces of fruit are apples? So notice now things have changed a little bit, because we're not putting that piece of fruit back before we draw a second, or before we grab a second one. So this time we're going to do the probability that the first one is an apple times the probability that the second one is an apple, knowing that the first one was an apple. So we just have to be a little bit careful. We have what we call dependent events here, because if I draw an apple out the first time, probability of an apple for my second draw has changed. So how many pieces of fruit do I have altogether? 13. 5 plus 8 is 13. So the probability of an apple in the first draw is 5 out of 13. But if I don't put the apple back, I eat it, then I have 4 apples left out of 12 pieces of fruit. And I will multiply using that multiplication rule of probability again. And I can reduce 4 out of 12 to 1 over 3. Multiply numerators, multiply denominators. My fraction answer is 5 out of 39. Do a little dividing. 5 divided by 39, I get for my decimal 0.1282. There's my decimal answer. And then my percent is 12.82%. Okay, number 4. You have a box that contains 4 red playing cards and 5 black playing cards. Now the red ones have the numbers from 1 to 4 on them, and the black ones have the numbers from 1 to 5 on them. So I'm going to randomly pick a card, and I want to know what the probability is that the number is less than a 4. Probability that the number on the card is less than 4. Oh, whoops. Red or has a number less than 4. So the probability of red or less than 4. So what I'm going to do is I'm going to look at my sample space, which is right here at the top of the page. Okay. And 4 of those are red, and 3 of the black ones are less than 4. So for my probability, it's just going to be 7 out of 9, because there are 9 cards in there altogether. There's my fraction answer. I grab my calculator, do 7 divided by 9. For my decimal answer, I get 0.7778. It's just a repeating 7. And then percent-wise, it's 77.78%. Okay, problem number 5. Probability of A or B. Remember, this is the or, this is the and. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both. That was the rule that we learned in our probability unit. So what we're going to do is we're going to take 11 over 20 plus 3 over 5 minus 33 over 100. And I'm going to either grab my calculator or do some fraction magic to get my answer. 11 divided by 20 plus 3 divided by 5 minus 33 divided by 100 is 0.82, or 82 over 100. Common denominator for those 3 fractions is 100. It comes out to 82 over 100, which, if we reduce the fraction, is 41 over 50. And if you need a decimal answer, it's 0.82. Or 0.82, and that is 82%. Okay, the last of the probability questions. You roll a fair 6-sided die twice. We're rolling it twice. I want to know the probability that the first roll is a 6 and the second roll is a 5. So a 6 and then a 5. All right, so what I'm going to do is use the multiplication property. I'll just write the number this time. Probability of 6 times the probability of 5, and the first roll does not affect the second one at all. Probability of 6 is 1 out of 6. Probability of 5 is also 1 out of 6. So the probability of the 6 and then a 5 is 1 over 36. Or if we change that to a decimal, grab our calculator, do 1 divided by 36. That is 0.2778. There's my decimal answer. Or if I need a percent, it is 27.78%. And that is the first page of probability, or the first page of the review.